6, we're going to be dealing with what are called arithmetic sequences. And don't look so excited about them. Really. The Monday blogs, here they are. Thanks a lot. Way to fire me up. Okay,
Yay.
Arithmetic sequences. Thanks, Trey. An arithmetic sequence, let's look up here at the top. An arithmetic sequence is a list of numbers. We'll also call them terms. So you have this list of numbers with another name for that. Instead of me maybe calling them a number, I'll say term with a common difference between each number. In other words, that there should be a constant going on. After you find the common difference, you can use it to continue the sequence. Now, there are different types of sequences, so you need to right away grab onto that. Even though we might not decide it's an arithmetic sequence, it could be a different type. But the only type we're studying in this lesson are arithmetic ones. Okay, we're trying to determine, is it an arithmetic sequence? So here's the first example. It's already done for us. Determine whether each sequence is an arithmetic sequence. If so, find the common difference and the next 3 terms. So notice, here's our sequence. 1, 2, 4, 8. They give us 4 terms. And if there's some sort of a pattern, we could find, that's an ellipse it's called. We could find, that's an ellipsis, I'm sorry. If we could find more of them. But we're just looking right now to see, first of all, is it an arithmetic sequence? Well, to get from 1 to 2, you have to add 1. To get from 2 to 4, you actually have to add 2. To get from 4 to 8, you have to add 4. So right here, the difference between the terms is not constant. There's not the same thing going on. So we say this is not an arithmetic sequence. We're not going to find the next 3 terms because we don't know what kind of sequence this is. We're only finding out, is it an arithmetic sequence? And it's not. So we're going to stop there and say, not an arithmetic sequence. The other example they have here for us, we have this sequence, 0, 6, 12, 18. Notice what's happening. What's going on? Between terms, what's happening?
It's going by 6.
It's going up by 6 every time. It's going up by 6. So we would say that it is an arithmetic sequence, and the common difference, when it is, we're going to have to be able to state what's the common difference. Okay? And there's going to be a little abbreviation for that, little d. The common difference is 6. Well, if the common difference is 6, then we should be able to keep finding more terms by just continually adding 6. So we add 6 to 18, our next term is 24. Add 6 to 24, the next term is 30. And add 6 to 30, and our next term is 36. Okay, so those are just some worked out examples for us already. Let's go do some together. It says fill in the blanks with the differences between terms and state whether each sequence is an arithmetic sequence. So to get from 14 to 12, what has to happen?
There's a decrease by 2.
Has to go down by 2. So let's call that subtract 2. Or add a negative 2. How about from 12 to 10? Rose? Subtract 2 again. How about from 10 to 8? Isaac?
Subtract 2.
Subtract 2. So is this an arithmetic sequence?
Yes.
Yes, it is. In fact, it is, and we would say that D equals what? Rose? Negative 2, yeah, minus 2. It didn't tell us to decide what the common difference was, but we'll just start practicing it right away. Okay, how about number 2? To get from 3/10 to 6/10, what do you have to do? What actually has to happen to get from 3/10 to 6/10? Riley?
Plus 0.3.
Plus 0.3, plus 3/10. So 0.3. To get from 6/10 to 1 0/10, what actually has to happen? Right?
Plus 4.
Plus 4 or plus 0.4?
0.4.
Yeah, plus 0.4. To get from 1 0/10 to 1 5/10, what has to happen? What actually goes on to get from 1 0/10 to 1 5/10?
Plus 0.5.
Yeah, plus 0.5, add 5/10. So is this an arithmetic sequence?
No,
Why not?
because it's going up by 3 and 4.
Because it's not the same, is it? It's not a common difference. It's not a constant. So we would say no to this one. We don't have to identify D because it's not an arithmetic sequence. Okay, so you'll be doing some of that in your homework. Just identifying, first of all, if it is an arithmetic sequence or not. And then if it is, let's identify what our common difference is, what our D value actually is. So anybody have questions in that little section? Okay, how about our next one? Use the common difference to find the next 3 terms in each arithmetic sequence. In other words, they've already started it and said, oh, it keeps going down by 3, so what's our next term going to be? What's negative 2 going down by 3, Rose? Negative 5. Well, now it's at negative 5, and it's going to go down 3 more. Trey? Negative 8. And now it's at negative 8, and it's going to go down 3 more. Now where's it going to be at? Brighton? Negative 11. And this pattern, that's what this ellipsis means right here, those 3 dots. That means this pattern just goes on and on and on. Same pattern forever. We could get lots more terms. In other words, there's an infinite number of terms. Okay, the next arithmetic sequence we have has a common difference of what?
Plus 5.
Adding 5, so a positive 5. So, Seth, what's our next term going to be in this sequence?
15.
15. JC, what's the next one going to be?
20.
20. Ariel, what's the next one going to be? 25. And that pattern goes on and on and on. Okay. So finding next terms, and these commas get kind of small here. There are commas in between terms of an arithmetic sequence, or between terms of any sequence for that matter. Right.
For number 4, how come it doesn't have the rest of the 5s underneath?
Because we didn't put them there. We're going to do that. Thanks. Plus 5. That's our work, right? Plus 5. Plus 5. Don't anybody be mad at them because you just created more work. That's important. So yes, we should be showing that we're adding 5 each time, weren't we? We were doing it in our head, which is okay. Okay, any questions on that, other than the one that Brighton reminded us of? Okay, then let's look at the next set of directions. It says determine whether each sequence is an arithmetic sequence. So in other words, we have to look for a common difference, don't we? If so, find the common difference and the next 3 terms. So we're going to say from here to here, what do we have to do? From negative 1 to 2, what is that? Brighton?
Add 3.
Add 3. Okay. To get from 2, the second term, to the third term of negative 3, what do we have to do? What happens to get from 2 to negative 3, Brighton?
Minus 6.
Minus 6? You all agree? Rose?
Minus.
How about we just subtract 5, I think. Well, is it an arithmetic sequence? Has it already broke down? Yeah, this is already a problem. It's got to keep doing the same thing, doesn't it? Let's keep doing the same thing. So, not an arithmetic sequence. And we have our work there to support it. We say it goes up by 3 the first time. It goes down by 5 the second time. So this can't be an arithmetic sequence.
Plus 7.
It's a sequence, a different kind. And then the last one, it goes up by 7, doesn't it? Yeah. So it's kind of got this alternating positive-negative pattern going on. I wonder what kind of a sequence has that.
Pretty sure I'll play tomorrow.
We aren't going to have, no, we aren't doing that tomorrow. We haven't done that for a long time. Everything.
For those ones, do you want us to finish up with the problems?
We finish like we just did now with that plus 7.
Yeah.
It's a good idea too, just to kind of see what is going on, because eventually sometime you are going to learn and have to recognize what kind of a sequence that is. So you can, it is okay for us to just finish out the work, okay? Good question. Okay, let's do the next one. to get from the first term to the second term, what happens? Dakota?
Plus 250,
Plus 250,
350.
plus 0.250, okay?
3.
Oh, it's 3 now?
It's 2.
What is it?
It's 2.5.
It's 2.5. It's like $1.25 going up to $3.75, right? It goes up $2.50. Okay, and then because I wrote so big, I'm going to have to go above this time. What to get from 3.75 to 6.25
2.5.
goes up 2.5 again. Goes up 0.250 or 0.25. Either one's okay. And then how about our last one? And by the way, we do have to keep going because it can change.
2.5.
It does go up 2.5 again. Or 0.250, 0.2.50. Okay, so is this an arithmetic sequence?
Yes.
Yes. Is an arithmetic sequence. What does D equal?
Plus 2.5.
And you can leave the plus off if you want, because why? Why can we leave the plus off? We're just really, it is a positive, but you know what? It's okay to write it. It's not a big deal. Right? You can. You can. But here's what's going to happen. Now we have to find the next 3 terms. So the zero is going to come in kind of handy, actually, especially if you're trying to do mental math. If I treat these like money, whenever it's hundreds, I always treat it like money. So to find the next 3 terms, we actually have to start at the last term that was given to us. So, and you do have to show this work. Even if you're going to do it in your calculator, you got to show this. So we take the last term given, add our common difference. Who can do this without the calculator? What's $8.75 plus $2.50? Right? $11.25, $11.25, or 11.25. So we have to find the next 3 terms. Call the first one. Okay, and then now we are going to, what would our next set of words show? Mia? What do you think we'd show next? You're going to find another term now.
10.50 or 10.25 plus 2.50
Why 10.25?
because it comes after 8.75.
Nope, this is what we found our next term to be right here. In fact, you guys can circle that. That's one of our next 3 terms. So we're going to keep 11.25. We have to start plus 250. Okay, but now I had you engaged anyway. That was my main goal. You were off in another land. 11.25 plus 2.50, or $11.25 plus $2.50 is $13.75, or 13.75. We now have 2 terms more, and we need 1 more. So what are we going to do?
1375 plus 250 equals.
People, if you're going to work in retail, you're working at one of the food places, or you're going to work at the grocery store, you're going to work somewhere where you're handling money, they really want you to be able to do this in your test. What is this? 16.25. Yeah. Okay. So if it is an arithmetic sequence, we identify what our common difference is. We show the work getting the next 3 terms. Even if it's easy, even if it was 4 plus 2 is 6, 6 plus 2 is 8, and 8 plus 2 is 10, we show it. How do we get it, in other words? Okay, any concerns? Questions further? Okay, let's go to the back side. What if they say to you, oh, find the 50th term of this sequence and we're only going to give you the first 3? How many more would you have to find? 47.
Couldn't you multiply?
Could you multiply? Okay,
Yeah.
okay, maybe you could multiply because the shortcut for adding is multiplying. Okay, well then maybe there would be a way to just multiply instead of having to keep adding 47 times. So, in fact, there is a little formula, it's kind of a big formula. Here it is up here. It says, and it's kind of, kind of complicated. It looks really worse than it really is. A sub n means any term. What term you're told to find. A sub 1 stands for the first term. In other words, every sequence has to start somewhere. Plus, in parentheses, they have an n minus 1. That's the term number they want you to find. Take 1 away, because you don't need to work with the first one. We already have dealt with it right here in our A sub 1, and then multiply by the common difference. Or in other words, like JC said, why don't we just do some multiplying? Well, instead of continually adding and adding and adding and adding to that first term, take that first term and add to it how many times you would have had to add, multiplied by the common difference. So that's what they actually have done here in this example problem. Let's just take this complicated formula, let's take it all the way down to right here, okay? Look at it right here. A sub 50, we want the 50th term, that means, equals 5, which was the first term in the sequence that they gave us here. Here's our sequence up here, right here. There's the first term in it. The common difference is, or in other words, we have to keep subtracting 1.2. Well, instead of continually subtracting 1.2, you got to do it 49 times to get to the 50th term, don't you? So you would take 49 times the negative 1.2, and you know how much you really need to subtract. You need to subtract a negative 58.8. So we add 5 and a negative 58.8 and find out that the 50th term will be a negative 53.8. Now, here's where I really need you on board. I don't even necessarily care if you memorize that formula, but here's where I need you on board. You need to look at a sequence and you first need to determine, is it growing or is it shrinking? Is it getting smaller? So as you go along in the terms, this one started at 5, it went to 3.8, then it went to 2.6, and then it went to 1.4. Is it growing? No, it's getting smaller. So if you ended up with the number, let's say you ended up with the number 53.8, a positive 53.8, would that make sense? That the 50th term would be 53.8? No, we need to right away make that connection that, you know what, I don't just get an answer, I see if my answer makes sense to what was going on here. Okay? So it makes sense that the 50th term would be a negative 53.8. Even if it's not exactly right, it makes sense anyway, because it kept getting smaller like it should have. Okay, so let's do some practicing on our own. We have the arithmetic sequence. All they're telling us is that the first term, a sub 1 equals 10. So our sequence starts with 10, that's what they're telling us. And the common difference is 4. So it starts with 10. Let's just kind of have a picture of what this would look like. 10 has a common difference of 4. What would the next term be? 14. It's got a common difference of 4. What would the next term be? 18. So what's it doing? Is it growing or getting smaller? It's growing. It's getting larger, isn't it? So what term do they want us to find?
What's 4?
Oh, they want us just to write the rule. Okay, we're just going to write the rule for them. Okay? So we need to write the rule, which would be a sub n equals, what's our first term? It's 10, but always starts with the first term. Well, they're not telling us which term they want us to find. They're just saying, what's the rule so that if I throw some out at you, you can do it. Well, we take the term they want us to find and we need to subtract 1 from it because we don't need to take the first term times anything. The first term was already there. So we have to take the first term away from the number they want. And in this case, we're going to multiply by 4 our common difference. Okay? So there's the rule for that one. All they're having us practice there is writing the rule. Now, if I said to you, find the 20th term, would you expect it to be bigger or smaller than 18?
Bigger.
Bigger. Okay. Number 8. We're going to get ready to do the rule that we have like here. So we're going to do a rule, a sub n equals, we're going to do the rule. But we got to find some information here first. We got to identify the first term, the a sub 1. What is our first term in this one? -5. And the common difference, what's going on? What's going on in this sequence? -5 to 0, 0 to 5, 5 to 10. Cameron? It's being at, yeah, so it's a +5, isn't it? A +5. So our rule for this one would be a sub 1 equals -5, it has to start with, add to that, and then we're going to shortcut it by multiplying, but when we multiply, we have to subtract 1 from the term number that they want us to find, and then we're going to multiply that by a +5. So we need to be able to set up the rule so that we can use the rule when they say, oh, find the hundredth term. Trey,
Does the A have to be lowercase?
does the A, yes, it should be lowercase in this. And then the n should be subscripted there. So a sub n. Rose.
Just like your common difference, does it have to be a positive number?
Nope, your common difference can be negative also. Doesn't have to be a positive number. It's whatever is happening in the sequence. How is it changing by? Is it going up? Then it'll be a positive common difference, won't it? If it's getting smaller, then it should be a negative common difference. Yeah. Good question. Okay, let's go down now and practice. Let's look at number 9 here. Okay, what are some things we're going to need to identify when we look at our sequence? Look at number 9. Oh, they actually set up the rule for us. We're just going to find, which term are we finding?
30 seconds.
The 32nd term. It says over here, we need to find the 32nd term. So 32 is really our what? That's our n value. That's our n. There's our n right there. Okay, so we need to substitute 32 in for n. So we're looking for the 32nd term. That's what this says. A sub 32 says to the reader, hey, you're looking for the 32nd term of a sequence that starts with what?
6.
Starts with 6. And you're going to take, because you don't want to add 31 more times, you're going to shortcut it. And you're going to multiply. So 32 take away 1 will give us that 31. And we're going to multiply by 3. Because that's the common difference. They're already showing us that. So in reality, right now, I could start this arithmetic sequence and see. I could say it starts with 6. It's going up by 3s. 9, 12, dot, dot, dot. We're looking for the 32nd term down the line. So should it be bigger than 12? Yeah, we better end up with a number bigger than 12. So we're looking for 6 plus 31 times 3. In order of operations, do we add first or multiply first?
And
No,
what's what?
multiply. And you're going to make the mistake and add first. Be careful. You should not add first. You should multiply this 31 times this 3. Remember, we're shortcutting. 31 times 3 is?
93.
93. And this is a plus here. Okay, so 6 plus 93. 6 plus 93. The 32nd term is? 99. The 32nd term is 99. Now, sure glad we didn't have to keep adding 3 98 times, huh? That would have been a lot of work. Okay, or 31 times would be, not 98 times, 31 times. Okay, anybody got questions on that one? Because this is the kind of work you would need to show. You don't just put it in your calculator, do it, and say, okay, the 30-second term is magically 99.
So couldn't you just get 32, multiply it by how much it's going up by, and then add it to the last one,
To the first term or the last
the
term?
last term?
Last term? Well, okay. So if you want the 30-second term and you add it to this one, this is the what term right here? This 12 is the third term. So if you're going to take it times 32, the common difference times 32, you're saying you would really add 32 more times, wouldn't you? If you're going to shortcut like that. So you're going to add 32 more times. Well, we already have 1, 2, 3 terms. If you add 32 more, what term would you actually be getting? 1, 2, 3. You're going to add to this one 32 more times. What term would you actually be getting?
35th.
35th term, yeah. You'd actually be getting the 35th term if you did that. So we got to take into account that we start somewhere and we add one less time than the term number we want. Or we're going to get further down the sequence than we want. Okay, well they just gave us a sequence here. We're going to have to work a little harder than we had in the last one. We need, what's this 100 representing again? The n. Okay, so we need an n. We got that. What else do we need in our little formula?
A.
We need an a sub 1. So what's our a sub 1? What's our first term? Negative 8. So we have our n, we have our a sub 1. What else do we need?
A D.
A d. We need that common difference. We need to know what we're going to multiply by. So we got to figure out what's going on here. What happens to get from negative 8 to negative 6?
Add 2.
We got to add 2. Does that keep happening? To get from negative 6 to negative 4? Is that
Yes.
adding 2? Okay.
Yes.
To get from negative 4 to negative 2? Add 2. Okay, feeling pretty good about that. Our common difference is what?
2.
2. It's a positive 2, because we were adding 2 to get to the next term. So I think we have enough information now, right? To set up our problem. We are looking for the 100th term. So a sub 100 equals, start with the first term, add 100, take away 1. We don't want to add that first term back in. It's already there. So 100 take away 1 times 2. There's our shortcut. Instead of having to add 2 99 times, we're going to shortcut it. So we have negative 8 plus 99 times 2.
1,880.
Should we, what would be our next step?
0.99 times 2.
We're going to take 99 times 2, and we need to show that. Don't you just give me what the next term is. You show me that you multiplied next, even if you used your calculator to do it. What did we have to do next? So we're really adding 198 to our first term, and so our 100th term is, no, 190. It's 190. Our a sub 100, our 100th term is 190. Do you think we have a good answer?
Yes.
Was our sequence growing or getting smaller? It was growing, and this is a number that would show growth, wouldn't it? Okay.